All right, number one here. This one, it asks you to just find an error in this person's problem. And so kind of what they're trying to do here is to prove that these are inverses. We did learn that you can do f of g of x equal to x. And so they're trying to do f of g of x here. So whenever I do these error analysis problems, I would just do the problem myself. And so I would just say do your work kind of over here, and then find out where your work does not match up with their work. That's always my recommendations on the error analysis problem, so try that out. All right, next up, number two here, they're asking for g of f of x and its domain. And so g of f of x, that's where you plug in the f into the g. But with the domain, I'm going to just remind you that whenever we're doing domain on the composites, we need to look at domain restrictions of two things. And this was in our notes, of the inner function. And so in this case, the inner function is the f right there, and then also the final answer. And so you need to consider both of those two things. And so what would be restricted on the inner function and what would be restricted on the final answer. And the big thing to note there is that not the outer function. You don't worry about any restrictions of the outer function. And so in this case, the g on the outside, do not worry about the domain restrictions of that one. But you do need to look at the inner function in the final answer. All right, number three here, we have a select two that apply. And so this is asking about, they are told to find the inverse functions. So just keep in mind what the definition of inverse function is. Keep in mind how we find the inverse function. And that's going to really help you out on this one. All right, next up here, we just have a straight domain of a function. And so this is a radical in the denominator. And so anytime we have a radical is, our rules here for domain that we need to remember is a denominator cannot equal 0, and then the inside of a radical must be greater than or equal to 0. Now in this case, it's actually kind of a combination of those two because it's a radical in the denominator. So whenever that happens, it's just greater than 0 because it's greater than or equal to 0 because of the radical, but since it's in the denominator, that kind of takes away the or equals to. And so this is going to be x squared minus 9 is greater than 0. Now anytime that we have this or this with a squared or third power or any higher power, so anytime you have a higher power with the greater than or equal to, less than or equal to, you're going to need test points. And so we can see that that is the case here. We do need the test points because we have a higher power, a squared, any power higher than 1, with greater than or equal to, less than or equal to, with any one of those. All right, next up, number 5 here. And so for this one, they're giving you 3 functions up here. You got f, you got g, you got h, and then it's saying select 3 that apply. So you're just going to kind of work all of these out. So do f divided by g and see if it comes out to x minus 4. Do f minus h and see if it comes out to that. So just kind of testing all of those, adding, subtracting, multiplying, and dividing, and see what works. So 3 of them should work. All right, number 6 here, we have a table. And then I think this would be linear, so I would find the slope of this. And I would also find the y-intercept. And so I would get it in a y equals mx plus b form. And then once you get it in a y equals mx plus b form, you're going to kind of read the situations and see which of them. Remember that the b, whatever you get for that, is representing the beginning. That's what I call the beginning. And it's kind of like the initial value. So you are going to have to find that. It is not on the table, but if you find the slope, you're going to be able to figure it out. And then the m is going to be the rate of change. And so look for that in the situation. All right, number 7 is again linear here. And so if you look at the situation, to me, I see this as a point. So that's like 2.5 comma 1700. And then starting in an altitude of 400, that is our B. But it's also a point. It's also 0 comma 400. So remember the y-intercept is kind of a double piece of information there. So you can use it like that to find the slope. And so your final formula here should be in the form of mx plus b, except it's in t, so it should kind of be mt plus b. But you have to find m and b. Well, you kind of actually already know what b is, but you have to plug those in. All right, number 8 is our inverse here. Remember, and so for inverse, our process is switch x and y, and then solve for the new y. And so I'll let you guys do that. All right, next up here. So for this one, it looks a little more complicated, I think, than it actually is. So you're kind of just going to do it piece by piece. So like the furthest inside thing I see there is g of 4. So I'm going to find out what g of 4 is. And so that is, if I plug in 4 into this, negative 4 plus 5, that's going to give me 1. And so now if we kind of look back at the bigger picture, that's going to say f of 1 plus 3. Because g of 4 is 1, I can just substitute that in. And so now that's saying f of 4. So now you just have to figure out what f of 4 is, and then you're going to be done. All right, number 10 is another inverse here. And so for that one, remember, we just switch x and y and then solve for the new y. Number 11, we're doing f of g of x. So it's going to be f of 5x minus 3. And so that's going to be 5x minus 3 squared plus 1, because I took this and plugged it in for the x there on the f function. And so just make sure on this one that you FOIL the 5x minus 3, and then simplify. All right, number 12, we have another inverse here. And so I'll go ahead and kind of set this one up. So we're going to switch x and y. And then this is the one where we have two y's, so it's a little tricky. So I'm going to multiply the y minus 3 over here. And then I'll distribute that in there. So I get xy minus 3x equals 5y plus 2. So on this one, this is the one where we want to get everything with a y on one side, everything without a y on the other side. So I'm going to move the 3x over here. I'm going to move the 5y over here. I get xy minus 5y equals, let's see, 3x plus 2. And then next up, I'm going to factor the y out front, giving me x minus 5. And that allows me to divide that over to the other side. And so this would be my final answer, 3x plus 2 over x minus 5. The problem is I do not see that there. And so this will happen sometimes on these problems where that answer is not really there on a multiple choice. It is correct, but there's always an equivalent form of this, which is what happens if you multiply the top and bottom by negative 1. It will give you negative 3x minus 2 over negative x plus 5. And so that's an equivalent answer. Obviously, on a fraction, we're always allowed to multiply the top and the bottom by the same thing. And so the answer is then B. So I know that this answer looks a lot like C, but it's definitely not C because the 5 there is positive. And so don't pick an answer that's close. Honestly, if your answer is not there on these fraction problems, you need to make sure everything changes, and that's an equivalent answer. All right, next up here is number 13. So for this one, domain. Now, in this case, we don't have a radical, but we do have a denominator. So the denominator cannot equal 0. And so I know it's either B or D. And then with, on this one, here, remember when we need test points, if we have a higher power, which we do, with one of these guys. Now, you'll notice in this case, we don't have one of those guys, and so for that reason, we do not need test points. And so we don't need test points for the not equals to. We only need test points for these guys over here. So this one, if you were to do the domain, would just be everything else. I don't need to do test points because I don't need to worry about whether it's positive or negative. It just can't equal -3 or 3. All right, this one gives me a function here, and it says what's the average rate of change? And so remember, that's just a fancy word for slope on the first 1.25 seconds. So what we need to do here is we're going to do, we do f of b minus f of a over b minus a. Now our x values on this one, it says the first 1.25 seconds. So I'm going to go from 1.25, and actually this one's going to be 0. Because that would be kind of, we're starting at 0 and we're going to 1.25. And so this would be f of 1.25, and you would get that by plugging it in here. And then minus f of 0. And the trick on this one is that f of 0 is not 0. You need to actually, again, plug that into the function and find out what that is. So although this is f of 0, it's not 0. So the x value is 0. The y value is going to be something else. So you need to plug it in. All right, next up here, number 15. So on this one, it's at average rate of change. So again, slope between 1.5 and 3. And so once again, you'll do f of 3 minus f of 1.5 over 3 minus 1.5. And then you're going to have to interpret that. All right, number 16, you're going to need to figure out which one of these has this domain. And just remember, for domain, our rules is that a denominator cannot equal 0, and that the radical, the inside of the radical, must be greater than or equal to 0. 17 is transformations, so you can check that one out. You can look back at your notes if you need help on that one. All right, last up here, we have the average rate of change from f of a plus h, or sorry, from a to a plus h. And so I would do this as, I would do the a plus h first always, and then do the a over here. And so then this one is going to be 3a plus 3h if you plug in a plus h, and then this will be 2a plus 2h minus, plus 1 minus 3a over 2a plus 1. So I plugged in a plus h and I plugged in a. And so the next thing I would do, well, first of all, you can cancel out these a's, but don't forget we are going to have this h still on bottom. And then we're going to need to do common denominator. And so this one is going to have to multiply by 2a plus 2h plus 1. You can't just add the 2h there. You have to multiply this. And then this one over here is going to be multiplied by 2a plus 1. And so you're going to have to then simplify the numerators. You're going to want to keep the denominator in the factored form. So it's going to be here 2a plus 1 times 2a plus 2h plus 1. You don't need to multiply that part out. But this one, you're going to have to do a FOIL. Figure out what goes there. And then this one, you're going to have to distribute this as a -3a. So that's going to go up there. Don't forget that this is all over h, so I'll let you guys try that out.